Today we're going to take a look at dividing rational expressions. So dividing rational expressions is very similar to dividing fractions with multiplying fractions, multiplying rational expressions, all kind of that same type of concept. Like if I had, let's say I had 5 over 12 divided by 10 over 3. If we're dividing just those fractions, what we would do is we would keep 5 over 12 as is. We would change division to multiplication. And then we take the reciprocal of that second fraction. So 10 over 3 would become 3 over 10. And then we would start to make some simplifications. So 5 and 10. So 5 goes into 5 once. 5 goes into 10 twice. 3 goes into 3 once. 3 goes into 4. 3 goes into 12 4 times. So then we have 1 over 8. So we have 1 over 8. Same thing with rational expressions. Same exact concept. So let's look at this example here I have right here in the middle. 3x over 5y divided by 2x over 15xy. So we're going to keep the 3x over 5y, not going to do anything to that, change division to multiplication, take the reciprocal, so 15xy over 2x. And then we can start to make some simplifications if possible. So first thing I'm noticing here is I have x over x, those are going to cancel out. Then I know I have another x, but only one pair can cancel out. And then I have y over y, those are going to cancel out. I have 15 and 5. 5 goes into 5 once, 5 goes into 15 3 times. And then I think that's it. So on top, 3 times 3 is 9. And then I have that factor of x. And then on bottom, I just have a 2 left over. So 9x over 2. So if you know how to divide fractions and multiply fractions, then dividing rational expressions, and similar to multiplying rational expressions, shouldn't give you that much of pushback. So let's look at number 5. So first thing I would do, I would just get in the habit. I see division, I'm going to change that to multiplication, take the reciprocal. So I wouldn't, you could factor everything if you want while you're doing this, but just make sure you're realizing this is a division question. You're not able to simplify until it becomes multiplication. Like what I mean by that is here, look back at this first example. In this current state of division, you might see this, 3 and 15. 3 goes into 3 once, 3 goes into 15 5 times. But you can't do that because it's division. So you have to change it to multiplication, and then you can start to make some simplifications. So let's just get in the habit of doing that. So I have x squared minus 9, x squared minus 4 times x plus 2 over x minus 3. And obviously you can factor as you do this, like you don't have to rewrite it as a whole new problem every single time, but just for this first one at least, I'll show you that process. So I wrote as multiplication, I took the reciprocal of the second fraction. Now we look to factor everything on the top left. I have a difference of 2 squares. So that's going to be x minus 3 times x plus 3. On the bottom, x squared minus 4. That's another difference of 2 squares. So x minus 2, x plus 2 times x plus 2 over x minus 3. So that's not, there's no factoring or anything like that. So I'm going to leave this as x plus 2 over x minus 3. Now, it's a multiplication of rational expressions problem. So we can start to simplify. So x minus 3's cancel. X plus 2's cancel. What am I left with? I am just left with a factor of x plus 3 over a factor of x minus 2. So there we go. So understand the process of division. Got to change to multiplication, take the reciprocal, and then you're good to go with your understanding of multiplying rational expressions. Number 6. We have division, so I'm going to change that to multiplication. I'm going to knock out 2 steps in one here. I'm going to change to multiplication, but I'm going to factor everything also. I'm going to take the reciprocal, but I'm going to factor. I don't want to rewrite all this again. So let's factor. So we have a bunch of trinomials. We have a difference of 2 squares. So factoring this first trinomial, x to the second plus 3x plus 2. So 2 numbers that multiply to 2 add up to 3. That's going to be x plus 2 and x plus 1. On the bottom, 2 numbers that multiply to 6 add up to 5. That's going to be x plus 3 and x plus 2. 3 times 2 is 6. 3 plus 2 is 5. Take the reciprocal. So I'm going to flip this while also factoring. So difference of 2 squares for x squared minus 4. That's going to be x minus 2, x plus 2. And then the trinomial that's going down to the bottom now. 2 numbers that multiply to -2 add up to -1. That's going to be x minus 2 and x plus 1. Now we hope some things cancel out. So what do we have? All right, this first term, x plus 2. Do I have an x plus 2 in the denominator? Yes, I do. So boom, bam, gone. X plus 1 over here. Boom, boom. X minus 2, boom, boom. And then all I'm left with is the x plus 2 and the x plus 3. X plus 2 over x plus 3. Nice, that was a fun one. I like that. I like when there's a lot factoring and then there's some cool simplifications that can be made. Those are fun. Let's keep going. Number 7. 6x squared minus x minus 2. It's a division question, so let's make sure we're changing this to multiplication. Take the reciprocal. So I'm going to factor everything as I change. So this one, this 6x squared minus x minus 2, we do have to use AC method there. So I'm going to do 6 times negative 2, which is negative 12. And we want two numbers that multiply to negative 12, add up to negative 1. That's going to be negative 4 and 3. So I'm going to factor this over here. So 6x squared minus 4x plus 3x minus 2. So I'm just using AC method on this. Factor by grouping now. I'm going to take out a 3x. No, I'm not, sorry, 2x. I meant 2x. And that's going to leave me with 3x minus 2. From the second group, I don't have anything I could factor out, so I have to factor out something, and that's just going to be a 1. So 3x minus 2. Whoops, no, didn't mean to do that. And then I factor out the 3x minus 2, factor out the 2x plus 1. So I'm left with 3x minus 2, 2x plus 1. Heavy factoring there. On the bottom left, x squared plus 3x minus 10, two numbers that multiply to negative 10, add up to 3. That's going to be x plus 5 and x minus 2. 5 times negative 2 is negative 10. 5 plus negative 2 is positive 3. Now remember, we're changing this division, take the reciprocal. So this one is coming up here, and I could factor out a GCF of 2. So 2 times x minus 2 over, and then this one, oh, this is a cool factoring right here. 9x squared minus 4. This is a difference of two squares because 9 is a perfect square, 4 is a perfect square, x squared is a perfect square. So this is actually going to be 3x minus 2 times 3x plus 2. That's pretty cool. Now, what simplifications can we make? Well, 3x minus 2, 3x minus 2. Cancel out. I have a 2x plus 1. Do I have anything with that? Nope. All right, leave that alone. X minus 2. Do I have anything with that? Yes, I do. X minus 2, x minus 2. So I think that's it. And always check this. Like, we factor out a GCF of 2 here. Just double check, make sure there wasn't a 4 or a 6 or another 2 somewhere that we factored out and there wasn't. So we are good with that as our answer. So that's going to be 2 times 2x plus 1 over x plus 5 times 3x plus 2. There it is. All right, not a bad problem. Just know your factoring. It's really what it comes down to. Just know your factoring. And then also in this video, I wanted to talk about conversions. So converting as indicated here. So this is just like your common like inches to feet type of conversion. This is going from square units, so square feet to square inches, or square feet to square yards, or miles per hour to feet per second. So this is not as easy as just like how many inches are there in a foot, or how many feet are in a yard, that kind of thing. It's a little bit more complicated because we're talking about square feet. So we want to convert 9 square feet to square inches. So here's the process. Here's what we want to think about. I have 9 square feet. So I want to multiply that by a fraction that will allow the units of square footage, excuse me, square feet to cancel out. That's what I want to have happen. I want to convert this, so how many square feet are in square inches? Like I want it makes that some sort of conversion there. That's what my goal is. So I want to know how many square inches are in a square foot. So 1 foot what did I just write? Foot, there we go, is 12 inches. So 1 foot is 12 inches. And we want to convert this, though, into square inches. So what you want to think about well, how many, so like 1 square foot is equal to how many square inches is what we're trying to figure out right now. Trying to think about 1 square foot is how many square inches. Think about it visually. If I have a square 1 foot by 1 foot, the area here is 1 square foot. 1 feet squared. Well, if I convert that to inches, if I'm trying to get that in terms of inches, we just said 1 foot equals 12 inches. So this would be 12 inches by 12 inches. So how many square inches would that be? 12 times 12 is 144. So this would be 144 square inches. So you see the conversion there? A 1 foot by 1 foot square is equivalent of a 12 inch by 12 inch square. So if the area of a 1 foot by 1 foot square is 1 foot squared, then the equivalent would be 144 inches squared. So 1 square foot is equal to 144 square inches. So 1 square foot is equal to 144 square inches. So the cancellation here is square feet over square feet. Those units drop out. So then we just have 9 times 144. So 9 times 144 is 1296 square inches. So that means 9 square feet is equal to 1,296 square inches. Let's look at the next one. Now we're going to go from square feet to square yards. Square feet to square yards. So 1 yard, just knowing conversions here. So 1 yard is 3 feet. And what we want to have happen, so I have 72 square feet. I want to multiply this by some factor where the square feet will cancel out. And then I want it to be in square yards. That's what my goal is right now. I want these to cancel out, square feet to cancel out, and I'm left with square yards. Okay, so that's what we got to think about. So I'm in square feet, and I just need to know, well, how many 1 square foot or 1 square yard is equal to how many square feet? Can't write right now. Square feet. So let's do the same exercise as we just did with the inches and feet. So we know 1 yard is equal to 3 feet. So if I have a 1 by 1 yard square here, the area is 1 square yard. Okay? What if it's in feet? Well, 1 yard is equal to 3 feet, as I just explained. 3 feet. 1 yard is equal to 3 feet. So a 1 yard by 1 yard square is a 3 foot by 3 foot square. What is the area of that square now? 3 times 3 is 9. So 9 square feet. So if we have 1 square yard, that is equivalent of 9 square feet. So there's our conversion. So 1 square yard is equal to 9 square feet. So these square feet cancel out there. So since the square feet cancel out, I'm now doing 72 divided by 9, which is 8, because I'm not multiplying, because we had 1 square yard is equal to 9 square feet. So the conversion here is 1 over 9, where before the conversion was square inches and square feet. So 1 is on bottom, and then 144. So that's going to be 1 over 9, which is 72 divided by 9, which is 8 square yards. So 8 square yards. Yeah, the square footage, square yards, square inches, like that kind of, like when you're looking at it as a square unit, gets a little bit difficult. This next one, we're going from 25 miles per hour to feet per second. So 25 miles per hour to feet per second. A couple conversions we need to know. First of all, we need to know hours to minutes, minutes to seconds, and then we can go from hours to seconds. So 1 hour equals 60 minutes. Then we know 1 minute is equal to 60 seconds. So 1 hour is equal to 60 minutes. 1 minute is equal to 60 seconds. So then what is 1 hour in seconds? And the reason we care about this is because we want to go from miles per hour to feet per second. And you could make a little bit of a longer conversion, like going to hours to minutes and then minutes to seconds and then getting it like that. But we could just make one quick jump from hours to seconds by understanding, well, 1 hour is 60 minutes, 1 minute is 60 seconds, 60 times 60 is 3,600 seconds, 60 times 60. So this is just 60 times 60. The other conversion we need to know is miles to feet. So 1 mile is equal to how many feet? And that's 5,280. Not sure how common knowledge that is, but that's 1 mile is equal to 5,280 feet. So here's how we want to understand this. 25 miles per hour is 25 miles per 1 hour. So I want to multiply by some terms here that will allow the miles and hours to cancel out and give us feet per second, because that's what we want. We want, in the end, we want feet per second. That's our end goal. So let's check this out. Let's see how we do that. So first of all, let's get the hours to drop out. So hours, we already said 1 hour is 3,600 seconds. So 1 hour is 3,600 seconds. And the reason I'm writing it like that is because hours were right here. So then hours and hours will cancel out, leaving us with miles. Or I'm sorry, not miles, seconds. And then we want miles to drop out. So what should we multiply by there? Well, that's going to be the miles to feet conversion. So that's 5,280 feet and 1 mile. So in that way, miles drop out. That leaves us with the 5,280 feet, and then we are left with the seconds. So in the end, we'll have feet per second. So we're going to multiply across the top, divide by 3,600. So I'm just doing 25 times 5,280 divided by 3,600, because 3,600 is on the bottom, and that's going to leave us as 36.67 feet per second. So the key here is trying to find those dropouts, like trying to find miles dropout. Hours drop out. And then what are we left with? We're left with the feet per second. And it would just convert to a decimal. It kind of depends on if you're trying to keep it as fraction form, but we'll just leave it like that, 36.67.